Are we going?
You had one shot.
Okay. Don't stop. Just keep going. Okay. Alright, ready. Hello, world.
I'm Austin,
I'm Kevin.
I'm Sang.
and we're Team AK-15.
Our Engineering 6 project allows you to analyze commodity prices.
Alright, we can start the program by inputting GUI. The menu pops up. The user has the option to choose commodity price indices or individual commodity prices. As we press one of the buttons, the pop-up menu changes. And as we select an item, the first stat text shows the name of the item, and the second stat text shows the price available for the item. And then we can continue to graphing options. As you can tell, on top of the GUI, you can see the commodity selected. The user has 4 graph options. The user can choose what type of graph that he or she wants: point-to-point graph that shows monthly or yearly change, or a box plot that shows quarterly or yearly highs and lows.
When the user selects year-to-year prices, they're prompted with select month to analyze. The month they select is used as a target in the next graph that will show data on every given month for the next set of years. For month-to-month prices and the 2 box plot options, the user is prompted with a range of years. They're shown the data availability for these years, and they can enter in the years that they want to analyze. When the user selects year-to-year prices and a month, the graph appears. The code behind it first selects the prices for the commodity. It then finds all available dates for the commodity using isNone and all available prices. The data is then specified down to the user inputted years using a 12-step to find the appropriate month. It is plotted, and the rest of the code is dedicated towards labeling and titling the graph. When the user selects month-to-month prices and specifies a range of years, the graph is displayed. First, the start and the finish dates are put in simpler terms, and then the data is loaded. The prices, dates available, and dates chosen by the user are all specified, and then plotted. The rest of the code is dedicated towards labeling and titling the graph. When the user selects yearly box plot and enters a range of years, the graph is displayed. The previous code for obtaining prices, dates available, and user-specified dates is reused, but rather than immediately displaying the plot, the data must first be synthesized. Using a for loop, the data is analyzed in blocks of 12 months and finds the highest value, the lowest value, and the average, and places these into an array. An error bar is displayed after this for loop, and it is titled and labeled. When the user selects quarterly box plot and enters a range of years, the graph is displayed. A process similar to that in the yearly box plot is executed. The only real difference is that it is analyzed in sets of 3 months rather than 12 months.
Our program also allows you to predict a future price using an exponential moving average, or an EMA. What an EMA does is it uses previous data points to smooth the curve and remove some of the noise that happens in day-to-day trades. Since it's an exponential moving average, it gives a lot more weight to data points that are closer in time, more recent in time. How the EMA is set up is it takes the value for today's EMA is determined by taking the EMA value of yesterday and then adding the difference between the price today and the EMA of yesterday multiplied by this value K. K is a smoothing constant. The higher the value of K, the less smoothing the EMA is going to do, and the more weight it will give to recent prices. As such, it's better at following short-term movements. The lower your K, the better it'll show you long-term trends. So to create our EMA, we have to determine two things. The first is the initial value of the EMA. Since an EMA uses previous data points to determine the current value, you do need to initialize the first one. To do this, I took the mean of the first five values, the first 5 prices that we have available. This creates a good starting spot to move from. The second thing you need to figure out is your value of K. If it's too high or too low, it won't do a very good job of predicting future prices. Now, since a lower value of K is more indicative of long-term trends, if you have a lot of data points available, a lower value of K will help you. And so data avail helps find the number of data points you have to work with. Now, the volatility of a stock, or how quickly it changes price, also has a big impact on whether your value of K will be successful. So I looked at how the commodity changes over 6-month periods, and if it either spikes or is pretty constant. Now, adding all that information together, you create the optimized value of K. Our program offers support to predict the future price for 4 commodities: copper, cotton, cocoa beans, and aluminum. When you continue on to your graphing options, you'll see there's one new one: predict today's price. Clicking that button activates the EMA and uses the polyfit and polyval functions to extend the EMA on one more period and predict the price today. We also use URL read to go fetch the actual price from the Wall Street Journal, and you can see the comparison here. After clicking OK, you can see a graph that shows the market price in blue, the EMA in green, the prediction as the red star, and the actual value of today as the blue star. Zooming in shows that while it's hard to predict the stock market, we didn't do too bad.